A very good morning, students. Welcome to the lecture series on operating systems. In this session, we are going to discuss about interprocess communication. The importance of the interprocess communication. Coming to that, before going to discuss about interprocess communication, we are highly essential to discuss about types of the process also. There are two types of process. One is dependent process and other one is independent process. In the case of the independent process, there is no question of sharing of information from one process to another process. The execution of one instruction or one process doesn't affect or affected by the other process. In the case of the independent process, there is no question of sharing of information. Due to that reason, interprocess kind of communication is not at all required in the case of the independent process. Then, coming to the cooperating process. In the case of the cooperative process, the execution or the sharing of information from one processor to another processor is highly essential. In the case of the cooperative process, execution of one process may affect or affected by the other processor. Due to that reason, the information sharing, resource utilization, computational speed up, modularity and convenience made very much possible in the case of the cooperative process through this interprocess communication. Interprocess communication is required in the case of the cooperative process only. And this interprocess communication is established through two kind of methodologies. One is message passing and other one is shared memory. Let us have the discussion about shared memory at first. Guys, here process A and process B, there are two processes. Process A and process B are the two processes. They want to communicate with each other through some messages. These messages can be done either through messages or through mailboxes. Okay, one is referred as a direct communication and other one is referred as an indirect communication. Okay, direct communication means we can share our message to the person directly. Otherwise, we can keep our mailboxes. Like in our regular scenario also, we can have our mailboxes, Gmail or Mail or something like that. Okay, we can have our individual mailboxes. And process A can share some information with the mailbox of process B. Okay, then process B replies to process A like in the form of a mail to the mailbox of process A. Okay, so direct communication is not at there. The communication is happening in between the mailboxes. It is referred as indirect communication in the message passing systems. Likewise, process A sends some message to the process B, like our telephonic conversation. In the case of the telephonic conversation, directly we send the message to the process. Okay, that is referred like a message passing through the direct communication. Okay guys, this is about the message passing, and likewise there is a shared memory also. And here process A and process B have interacted directly through the shared memory. If any of the processes which are sharing some space among them, then they can able to share the information, they can able to share the I/O devices. So interprocess communication can be established through two strategies. What are those two strategies? One is the shared memory and other one is the message passing. What are the other two possibilities are there in the message passing? There are two more possibilities. What are those two? One is direct communication and the other one is the indirect communication. What is the example of the direct communication? A regular telephonic conversation is the example of direct communication. What about the indirect communication? Indirect communication is example like through communication through mailboxes. Coming to the next example. Okay students, let us have the discussion about the shared memory. The communication can be happen in the shared memory only if the two processes are sharing the some space as a shared among them. For example, this is the shared memory among, there are two processes named P1 and P2. This is the space reserved for sharing. Through this shared memory, P1 and P2 can communicate with each other. Okay, thereafter, for example, in our university, data entry operator is consisting of a printer. This printer is shared through the other faculty also. So, if the printer is kept in the shared mode, then the printer is being accessed by the other faculty who are connected to that. Okay, so shared memory facilitates the resource sharing also in addition to the message passing. Okay, so the compared to the message passing, shared memory have further advantages like in addition to information sharing, there is a possibility of sharing the resources also in the case of the shared memory. Implementation of the shared memory is costlier than the implementation of message passing systems, because in the message passing systems there is no requirement of IO device, but in the case of the implementation of the shared memory, the cost is associated with it. Thereafter, the shared memory problem is just like a producer-consumer problem. For example, producer is a process. Producer is a process used to produce the items, and those items are required to be consumed by the consumer process. So whatever the items produced by the producer are going to be kept at one location, that is referred as buffer. That is referred as buffer. Buffer is a shared location where producer process is going to keep his items. Buffer is a location from which the consumer process is going to consume the items. So this buffer is going to serve as a shared space in between of the producer and consumer, where producer is keeping the items for after the production and consumer is going to consume the items from that particular shared location. Okay, now let us discuss about the buffer. Buffer have been categorized into two kinds. One is bounded buffer and other one is unbounded buffer. Based on the size we are categorizing them. Okay. If the size is limited, then it is referred as a bounded buffer. Means if the buffer capacity is limited, like 4 KB, 8 KB, 1 MB, 1 GB. Likewise, if the space, if the buffer space has been described in the finite space, finite number, then it is referred as a bounded buffer. If the buffer size is infinite, then it is referred as a unbounded buffer. In the case of the bounded buffer problem, if the buffer got full, then producer doesn't allow to produce the items, because even after that, if the producer is allowed to produce the items, then those items are going to be not able to be kept in the buffer. Due to that reason, the information loss is a possibility case in the case of the buffer is full. Okay, likewise, if the buffer is empty, then consumer could not able to consume the items from that particular buffer. Thereafter, consumer is supposed to block himself. Okay, let us have the discussion about this particular blocking in the further session. Okay, student, here we are going to talk about 2 pointers called in and out. In and out. Okay, in and out are going to be described like, for example, if the producer has produced the item, then he is going to keep his item in the in location. In is the location which points to the next free location. Therefore, the producer produces the item and he is going to keep that item in that particular free location. Thereafter, out is a point location which is going to describe very next full location. What is the meaning of the full location? Wherever the item is available, that particular item is going to be consumed by the consumer through that particular out point location. Okay, if in and out are equal, that describes the buffer is empty. In the case of the buffer is empty, what the consumer is supposed to do? Consumer is nothing to do anything, because if he wants to consume, there is no item, right? So he is supposed to block himself if the buffer is empty. Likewise, if in plus 1% buffer size equivalent to out, then that describes the buffer is full. In the case of the buffer is full, then the producer doesn't require to do anything, because even after that, if the producer has produced the items, he doesn't able to keep any kind of item in that. Therefore, producer should wait until the buffer is made empty. Now let us have the discussion about producer process and consumer process. Sir, whatever the item I am going to produce, that item is going to be kept in a location called next produced. This construct is basically used to describe about the producer problem. Okay, for example, I am assuming in plus 1% buffer size is equivalent to out. If this condition was satisfied, then it describes that already buffer is full. If already buffer is full, does producer can able to do anything? Nothing. Means buffer producer will be blocked. Otherwise, producer will produce the item. Whatever the item produced by the producer, that will be available in the next produced. That next produced item is going to be kept in the pointer location called in. It is already described, right? So I am going to keep that item in the in location. Buffer of in is equal to next produced. Okay, and I am going to increment the value of in now. So in is equal to in plus 1 percentage buffer size. Likewise, I do increment the value of the in pointer. And then coming to the consumer process. In the case of the consumer process, the item I am going to consume next is going to be described like next consumed. If in is equivalent to out, what it means? Buffer is already empty. If already buffer is empty, can I able to do anything? Nothing. So consumer is getting ID. Consumer will be blocked. Okay. Thereafter, if buffer is consisting of some items, in the case of buffer is not empty, then whatever the item I am going to consume is going to be described by a pointer called out. So buffer of out going to describe what is the item I am supposed to consume. So next consumed is equal to buffer of outer. Once after that, consuming of the item from that, I am going to increment the value of the out pointer. Like out is equal to out plus 1 percentage buffer size. Likewise, I am going to consume the next item from the buffer. The message passing systems, the messages can be exchanged by using two of the primitives called send and receive. Send of message means a user tends to send the message. Receive of message means a user tends to receive the some message. The message size is either fixed or a variable sized messages also. Like two of the process can communicate with each other only if the link has been established among them. That particular link has been established to exchange the information using the two primitives called send and receive. In the case of the physical communication, there is a physical transmission can be done through shared memory. In the case of the shared memory, hardware bus is required and the network is required to be established among them. But in the case of the logical communication, as I earlier said, there are two kinds of the possibilities. One is direct communication, other one is the indirect communication. In the case of the direct and indirect communications, there are two kinds of possibilities. One is either synchronous transmission or asynchronous transmission through the buffers. Now, let us have the discussion about direct communication. In the case of the direct communication, sender and receiver can directly share the information with each other. In this scenario, send and receive are the two primitives. Send and receive are the two primitives. Can share the information by mentioning the name of that particular process. Here, the example like send of a P comma message. What is the meaning of the send of a P comma message? Send a message to process P. Send a message to process P. Likewise, receive of a Q comma message. What is the meaning of the receive of a Q comma message? Receive a message from process Q. Likewise, the communication has been established among the two processes by mentioning the name. Then that is referred as direct communication. Okay guys? Thereafter, coming to the properties, these links have to be established directly or automatically. And once the link has been established among those two processes, then others should not be allowed to communicate with them. Then that is referred as hacking. Okay? If the two persons are allowed to communicate, then the information sharing need to be exactly happen in between of them. Okay? Coming to the indirect communication. In the case of the indirect communication, the messages are transmitted from one process to another process through mailboxes, and these are also referred as ports. These mailboxes are meant for sharing of the information and where the process are going to keep their items for the further discussions. Funny, remove further discussion point. A mailbox is an object which is meant to share some messages for the other processes, and each mailbox will have some unique ID. Okay? And process can communicate with each other by mentioning the mailbox ID. Okay, send and receive are the two primitives which are meant for implementation of the indirect communication among the two processes. Send of a comma message. What is the meaning of the send of a comma message? Send a message to the mailbox of A. Send a message to the mailbox A. This mailbox A is managed by some other process, right? Receive of a message, a comma message. What is the meaning of receive of a comma message? Receive a message from mailbox A. Likewise, we need to mention the name of the mailbox in our communication. Every mailbox will have a unique name. Okay. Coming to the properties of the communication link. A link needs to be established among the process to share the common mailbox. Because if we don't know the mailbox ID, the communication should not be established between us, right? So mailbox ID is supposed to be shared among them. And thereafter, a link need to be associated with the many process also. Means in our regular communication also, we are sharing our mailbox ID with n number of persons simultaneously, right? So more number of process even can possible to communicate with us through the indirect communication. Thereafter, it is needed to discuss about synchronization. How does this direct and indirect communications will be synchronized together? Then in this, we need to talk about blocking. Blocking is referred as a synchronous. What is the meaning of the blocking? As I earlier said, like if the producer has produced the items and he has kept some items in the buffer, if the buffer is getting full, then even after that, if we are allowing the producer to produce the items, what is the necessity of producing the items? Because there is no space to store the items, right? So producer is supposed to wait. Likewise, in the case of the consumer also, if the buffer is already empty, there is nothing to consume, then what is the necessity of a consumer problem to work? Then consumer need to block himself. Likewise, producer problem and consumer process, both of them will block themselves in the case of buffer is full and buffer is empty respectively. In this scenario, blocking sender. Let us be talking about blocking sender. In this scenario, the sender sends the message and blocks himself until the receiver receives the message. Means, for example, a teacher and student is there. Teacher has sent some message to the student. Teacher will block himself until the student has received the message. And thereafter, student will respond to that. Student will respond to the message to the faculty. Once after that, student will block himself until the faculty receives the message. Then it is referred as blocking send and blocking receive. In the case of the blocking send, sender sends the message and blocks himself until the receiver receives the message. In the case of the blocking receiver, the receiver is blocked until a message is available. If the message is not available, then what is the need of receiver to be available, right? Thereafter, non-blocking is referred as an asynchronous transmission. What is the meaning of that? Non-blocking sender means sender sends the messages continuously. He doesn't block himself. And likewise, in the case of the non-blocking receive also, the receiver is already, every instant of the time, the receiver is available to receive the messages. Either it is a valid message or a null message also. If both the sender and receiver have been blocked together, then that condition is called rendigious condition. In the case of the rendigious condition, both the sender process and as well as the receiver process will be blocked themselves. Coming to the synchronization. Synchronization can be achieved through three different kinds of scenarios. One is zero capacity and other one is bounded and finally unbounded. Okay, in the case of the zero capacity, means there is no specific buffer is there. Means sender sends the message and blocks himself. Why? Because there is no buffer to keep that item in the buffer. Okay. If there is no space to store the item, then obviously sender is supposed to block himself until the receiver receives the message. Once after recipients of the information from the receiver, further the sender is permitted to send the message. Okay, thereafter bounded buffer. In the case of the bounded buffer, there is a fixed space to store the messages. Okay, so sender sends the messages until the receiver receives the message and he should not block himself. He keep on continuously sends the messages. He stops the sending of the messages if the mailbox got full. If the mailbox got full, then automatically sender should not send the messages and he will be in a blocked mode. Okay, so this bounded buffer means the buffer size is fixed and only finite number of messages can be possible to be kept into the bounded buffer, and so continuously sender sends the messages until the buffer becomes full. Whenever the buffer becomes full, then automatically sender blocks himself. Okay, but in the case of the unbounded buffer, it is the meaning of a buffer with infinite capacity. Means sender should not block himself. He continuously sends the messages, whether the receiver receives the message or not. It is a continuous process. Okay, students, hope you got clarified about inter-process communication. Inter-process communication is meant to achieve the modularity, CPU utilization, and then convenience to the user. So all these things will be made possible in the cooperative process only. In the cooperative process, the communication can be established through two of the procedures. One is message passing and other one is shared memory. In the case of the shared memory, along with the information sharing, the resource sharing is also made possible, and it is a costly approach, and some I/O devices are needed to be allocated for it. And coming to the message passing. In the message passing, the communication has been established in two ways. One is the direct communication and other one is the indirect communication. In the direct communication, the communication has been established between the process directly by naming themselves. Thereafter, the communication has been established through two of the primitives called send and receive. And thereafter, the indirect communication has been established between the two of the process through mailboxes. And these mailboxes are also referred like ports. So the communication has been established through the mailbox by defining the mailbox ID. And then the communication between the either it is a direct or indirect communication, it should be either synchronous or asynchronous. The synchronous and asynchronous transmissions can be done through buffers. If the buffer of capacity is 0, then it is referred as an, in the case of the zero buffer, the sender sends the message and blocks himself. But in the case of the bounded buffer, producer continuously produces items and those are going to be kept into the buffer and he blocks himself until the buffer becomes full. Whenever the buffer becomes full, then the producer will be blocks himself until the consumer consumes those items. In the case of the unbounded buffer, the producer continuously produces items whether the consumer is consuming the items or not. Thank you, students.